Welcome back to the Functional Python series. In this video, I want to talk about comprehensions and why comprehensions are a form of functional programming. If you have been a Python programmer for a while, it's very likely that you have used comprehensions and also very likely that you love them. They're a very, very powerful construct. As usual, the code for this video is in GitHub, and there's a link in the description to it. Let's recapitulate from the previous video. We talked about map and filter, what they are and how they can be used. And I had this example in that video. Essentially, I'm using map and filter to create a list of numbers that they are between 0 and 9, that they are even. But I also want to I want to pair them with their square, okay? So when I run this code, I get numbers 0, 2, 4, 6, and 8 with their corresponding square. Okay, so let's rewrite this code in a more Pythonic way. So let's do the return, and I'm going to use parentheses. And here I'm going to take the body of the lambda of the map at 4x in stream if, and here I'm going to use the body of the filter lambda, and I only need one parenthesis. I think this is correct, so let's run this code. Two. So let's run the code. As you can see here, this is original map and filter and map more specifically, and here's the output of the new code with the generator. As you can see, when we print the streams, in one we see it's coming from a map, in the other one it's coming from a generator. This type of comprehension is known as a generator. I'm going to call it generator comprehension to be specific, and the result is exactly the same. Notice that in this case, the generator comprehension takes a stream, same as our original map and filter, and it does a filter followed by a map in that order, and then returns a stream. And this generator is lazy, okay? So as I mentioned before, the body in the left-hand side of the generator is exactly the body of the lambda of the map. And the body of the if section of the generator is the body of the lambda of the filter. Okay, so relatively straightforward. So that's why I say that a generator comprehension is a filter followed by a map, and the result is exactly the same. Both of them are generators, both of them are lazy, and both of them return exactly the same values when we evaluate the stream. Okay, we can have more than one if, that is possible. So let's say that we want to keep only the numbers that they are bigger than 5. So we can test first for this condition and then our other condition. We could have had an AND, but notice that by doing this, we're separating the concerns. We're making our code a little bit more readable, because we're saying first this is true and then this is true. And notice that I'm adding this new filter in my original function, and the two of them are still doing exactly the same. So if I run this code, you can see here the map object generates 6, 8 with their corresponding squares, and the generator object generates 6 and 8 with their corresponding squares. Okay, we don't need to use an if. In that case, it's essentially just equivalent to a map. In this example, then I don't have an if in the generator comprehension, and I remove the if of my original function. So we're going to get the square of all the numbers from 0 to 9. The number and the corresponding square in both of the two functions that we are creating. We can also have more than one for, and in that case, what we're having here is for I in stream 1, we're giving it a name I for each element of stream 1, and then we give the name j for each element of the stream 2, and what it does, it computes a cross product. So let's make a tuple with those results. And we're going to pass the range of numbers from 1 to 4 and from 0 to 4 and 0 to 2 in each one of the streams. This code is exactly identical to the one, functionally identical to using from itertools the function product. We pass the first stream, we pass the second stream, and then we compute the list. Why do I compute the list? Because again, they are streams, so they are lazy, they are not evaluated. And you can see here that the result is exactly the same. We're getting the cross product of all the elements of each one of the streams in both lines of code. Line 13 does exactly the same as line 18. What if we use brackets instead of parentheses? In that case, then the generator stream, the generator comprehension becomes a list comprehension. It does the same as before, but instead of returning a stream that is to be traversed, it does it and returns the list. So if we run this code, we will actually see that our original function returns the stream, while the comprehension function returns the list already evaluated. If we wanted to have exactly the same functionality, we'll have to say list of stream. And then when we evaluate them, they are exactly identical. Okay. So what is the disadvantage of using the brackets? The evaluation is no longer lazy. It happens at that moment. If our stream is huge and we don't want to traverse it all, this will create a list with every single value of the result of the comprehension. So depending on where you use it, how big the input is, you might need a lot of memory that you don't need if you use the generator comprehension. So what is the main drawback of the generators? I think that the main one, or the only one I could find, is that the filter happens before the map. So if you have logic where the filter happens after the map has been applied, then you might have to duplicate the functionality of the filter and perhaps have extra computation. But that's a relatively minor drawback. So in conclusion, a generator comprehension is essentially functional programming. It's equivalent to 0 more filters and at least one map in that order. And they are lazy. They're lazy computation. Again, as usual, the code for this video is in GitHub and the links is in the description. And I'll see you in the next video.